Welcome to my second video in my series on energy. In this video, we're going to go over kinetic energy and look at a couple of examples. Previously, what we had done in kinetic energy, we know that mechanical energy can be broken down into kinetic energy plus the potential energy. And so this is where like a system is in motion would be the kinetic energy. And then the potential energy would have to do with gravity, be the gravitational potential energy. And we're just confining this to a mechanical system, meaning we're not worried about chemical or electromagnetic or nuclear types of energy. So it's got to do with an object moving basically on the face of the earth. So that's kind of where we're confining this. And then ME is going to be our mechanical energy. So that's kind of what we're looking at here, this subset. Our equation for kinetic energy, remember from last video, is 1/2 mv squared, where m is going to be our mass, that's expressed in kilograms in the SI system, and then our velocity, v, is expressed in meters per second, and then our kinetic energy is going to be equal to, it's going to have units of our kinetic energy in units of joules. Now a joule is the equivalent of 0.7373 foot-pounds in the imperial or the English system, and also can be broken down to in the SI system as kilograms, meters squared per second squared. If you just look at this equation and do a unit analysis, so that's going to be the units of the joule. Let's look at an example here. So we want to find the kinetic energy of a baseball thrown at 40 meters per second. And the mass of a baseball is going to be equal to 0.0145 kilograms. Now, on a baseball, 40 meters per second roughly works out to 85.9 miles per hour in the English system. So that's basically what a standard, that would be considered a regular basketball in the Major League Baseball. And then this 0.0145 kilograms, that works out to around 5 ounces. So that is a standard baseball. So we're throwing a standard baseball and a regular pitch in a Major League Baseball game. So kinetic energy is equal to 1/2 mv squared. So that's equal to 1/2, and then our mass is 0.0145 kilograms. And then our velocity, we know, is 40 meters per second, and that's quantity squared. Now let's get our TI calculator out and calculate that up. Let's see, turn it on, and let's see. So we've got, start with 40 squared times 0.145 times 0.5, that's our half. And we're going to get 116. So that's 116 joules of energy. That's going to be the amount the baseball, by the time it goes across the plate at basically 90 miles an hour, that's how much energy it's going to have. Now we're going to compare that to another example. And this time, our example 2 is going to be a 1,500 kilogram car traveling at 25 meters per second. Let's find the kinetic energy. So there's our example. So a 1,500 kilogram car, that's equivalent to roughly 3,300 pounds if we convert that to the English system. And that's going to be the equivalent of a Toyota Camry. just to kind of give you an idea of what kind of car we're talking about here. And the 25 miles per hour, that's going to be 56, 25 meters per second is equivalent to 56 miles per hour. So basically we have a Toyota Camry traveling down the highway at about 56 miles per hour. So that's what this is equivalent to if we think about this in the terms of English units. So it's a realistic problem. So we've got kinetic energy is 1/2 mass times velocity squared. Our mass in this case is 1,500. And there's units of kilograms. And our velocity now is 25 meters per second squared. Let's get our calculator out and do the math on this. First, we want to clear it. So we've got 25 squared times 1,500 well, let's do a times 0.5. Let's do an enter now. Okay, so we're going to get 468,750. We don't need all those digits, but that's going to be units of joules. Now, if we convert that to scientific notation, we 1, 2, 3, 4, 5. So that is going to be equivalent to 4.69 times 10 to the 5th joules, converting it into scientific notation. So there's, and you can see that's considerably more than our baseball, which is at 116 joules. So that's a huge difference, and we would expect it. We've got a much larger mass. Car is much bigger than a baseball, obviously. Well, I hope you got something out of this video, learn a little bit more about kinetic energy, and a couple examples always help. So thank you for watching, and leave me some comments if you got any questions or anything you'd like to express. Thank you. Bye.